All right, well, it's an honor to be included as a member of the Academy, and it's a pleasure to share with you some of the work that we do in my lab, as well as some ideas and hypotheses that we're considering moving forward. The work in my lab primarily focuses on the role of exercise on fat metabolism, on obesity-related health complications, in particular, insulin resistance and type 2 diabetes. And one of the things that we're keenly interested in the lab is this phenomena here, which is the excessive availability and the mobilization of fatty acids from adipose tissue into the circulation, subsequently into other tissues and organs. So it's clear that fatty acid availability is very high in obesity, as shown here. And I'm not just talking about concentration, and I'm talking about the rate of release of fatty acids from adipose tissue and their rate of uptake. And these are measured using stable isotope tracer kinetics. And as I mentioned, in obesity, there's often a very high rate of fatty acid release from adipose tissue, and subsequently a high rate of uptake into tissues like skeletal muscle, liver, the heart, that can, we believe, be a cause of many of the metabolic complications in obesity. So I want to talk a little bit about the proposed underlying mechanisms for this, for fat and fatty acids excessive fatty acids to induce insulin resistance. And this is a cartoon of the insulin signaling cascade, and the pink portion of this slide is the muscle. And I want to talk pretty quickly and hopefully simply through what may be underlying this phenomenon. So when fatty acids enter the cell, there are two primary fates. So one being to the mitochondria, where it can be used to make energy, and the other to be stored locally within lipid droplets, within triglycerides, within lipid droplets in the muscle cell. Some of the fatty acids can also form these what are often referred to as fatty acid intermediates, which include diacylglyceride, ceramide. And when fatty acid availability is very high, as in the case with obesity, they can cause some problems. They can outstrip the ability of the mitochondria to oxidize and outstrip the ability for these excessive fatty acids entering the cell to be stored, and can cause events such as increasing free radical formation, hydrogen peroxide. It also can increase these intermediates, these fatty acid intermediates, diacylglyceride and ceramide, which are known to be signaling molecules for increasing inflammatory stress. And this inflammatory pathway activation is known to impair the insulin signaling cascade, inducing insulin resistance. So we know that weight loss improves insulin sensitivity. So one of the most profound effects of weight loss is to improve insulin sensitivity or reduce insulin resistance. And we contend that a big portion of that is through its role in reducing fatty acid availability and fatty acid flux. And when we say so via some of our work done in my lab, where we had obese adults lose 12% of their body weight, and they lost with diet only, no exercise in this condition. And as a result, of their weight loss, this 12% weight loss, they reduced their fatty acid mobilization. Again, this kinetic measurement, this rate of availability. And they also increased their insulin sensitivity. Right, so this by itself is certainly not showing cause and effect, but what we did in this study was to test how important this reduction in fatty acid flux was to this improvement in insulin sensitivity. We infused lipid solution plus heparin overnight in these obese subjects who had lost their weight. So this is, again, the weight loss condition, infusion of the lipid. This is done in the hospital, infusion of the lipid and heparin overnight. And importantly, we titrated the infusion rate to match the availability of fatty acids that they experienced before they lost the weight. And our question is, well, how did that return of their fatty acid flux, how did that impact their insulin sensitivity? And it turned out it completely reversed the weight loss, the improvement in insulin sensitivity that they experience with weight loss, this overnight lipid infusion. So we conclude that the reduction of the systemic fatty acid availability is key to the insulin sensitizing effects of weight loss. What about exercise and exercise training, right? And we know classic adaptation to exercise training is to increase mitochondrial density and increase oxidative capacity, increase fatty acid oxidative capacity. Seems very favorable to the notion of more favorable disposal of the excessive availability of fatty acids. So in this same study, this is data I just showed you, that the improvement in insulin sensitivity with weight loss alone, we also had a cohort randomized to a group of where they lost the same amount of weight, 12% weight loss. In this case, they lost the weight through diet and exercise. And we found that the exercise really didn't add much. They improved their insulin sensitivity as a consequence of the weight loss, but the exercise training didn't further increase their improvement in insulin sensitivity. A bit of a kick in the gut for an exercise enthusiast, exercise physiologist. But we had thinking about this paradigm of elevated fatty acid availability. Now that we've increased our capacity to oxidize these fatty acids by increasing the mitochondrial density, and we've demonstrated these exercise trained subjects improve their VO2 max, they increase their in muscle biopsy samples, they increase their mitochondrial markers of mitochondrial density. And so thinking that this would then be, again, a favorable disposal site for the fatty acids. Again, these are the data I showed you before, that the lipid infusion reversed the improvement in insulin sensitivity found with weight loss. And again, we did the same thing in our cohort that was randomized to the exercise training, thinking that the increased mitochondrial density would now prove to be effective in managing this excessive fatty acid availability, but that was not the case. So what we conclude is that adaptations to exercise training, again, this mitochondrial classic adaptations, mitochondria improvement and increase in mitochondrial density, did not protect against fatty acid induced insulin resistance. So all is not lost for an exercise enthusiast. But even though we contend that exercise training and the adaptations to exercise training may not be that favorable in the construct of when fatty acid availability is high, such as in obesity, and people retain their insulin resistance. But what about acute exercise? Right? So importantly, in this data I just showed you, we had removed exercise. So our measurements were performed 3 days after the last session of exercise, removing what are known to be potent effects of insulin on insulin sensitivity by each session of exercise. And we wanted to look at this fatty acid paradigm, this paradigm of fatty acid induced insulin resistance, and how exercise, a single session, each session of exercise improves insulin sensitivity, which again, it's known to do. So we had subjects exercise and we elevated their fat. Actually, these were a lean population of subjects who we artificially elevated their fatty acid availability. And then in the hours after the exercise session, we found that fat oxidation was higher. So they were funneling more of their fatty acids toward the mitochondria. They were funneling, perhaps more interestingly to us at least, they were funneling a greater proportion of the fatty acids toward intramyocellular triglycerides. And we found that important proteins involved in the synthesis of these triglycerides were also upregulated in these hours after each session of exercise. And therefore, again, resulting in a more favorable disposal of the elevated fatty acids. And we found indeed that the reduction that these fatty acid intermediates were reduced, and the bar graphs shown above, and that also the markers of pro-inflammatory stress, in this case phosphorylated junk, was also reduced. And indeed, insulin resistance was completely reversed. So with each session of exercise, this fatty acid-induced insulin resistance was completely reversed. So that's fantastic, and we get that benefit of each session of exercise. Again, that's not new information. The health benefits of exercise, each exercise session have been known for quite some time, but this role that the changes in fatty acid metabolism within muscle playing a role in the insulin sensitivity was new and exciting to us. But all this is, each session of exercise does a fabulous job of helping improve insulin sensitivity, but it's still a bit of a Band-Aid, because when we're faced with elevated fatty acid availability, as most obese individuals are, that really is the problem. So we're interested in going to the source. So we want our newer directions. Again, we're very interested still in muscle metabolism and muscle fatty acid metabolism, but we're expanding into the realm of understanding, of trying to understand a bit more about what exercise, not with weight loss, but exercise per se, does on subcutaneous adipose tissue, which is the primary source of these elevated circulating fatty acids. So we know that adipose tissue does a lot of of very exciting things. It's not just that site of energy storage. That can release a lot of peptides and have a lot of biological effects. But in this case, we're interested back into the adipose tissue's classic role of storing triglycerides and delivering fatty acids to peripheral tissues. In this case, I have pancreas and muscle and liver. And we know that, as I just mentioned, that when fatty acid availability is very high, that can cause problems. I just talked about insulin resistance at the skeletal muscle in the pancreas can reduce insulin secretion, a host of problems in the liver. And so if we can if adipose tissue is more effective at sequestering those fatty acids, that seems like it may be a favorable event. And that leads to this hypothesis that that indicates the role, the hypothesis regarding the adipose tissue expandability. So it may not seem very favorable to expand adipose tissue, but what we're talking about here is under conditions when we do overeat, and I'm not talking about a single meal or a few meals, I'm talking about overeating to the extent where we're gaining weight. If we can effectively store that and expand our adipose tissue to more effectively or safely store those fatty acids, and less fatty acids are going to the peripheral tissues, that's beneficial. Right? And conversely, under conditions when the adipose tissue cannot expand effectively, as is the case, unfortunately, in most obese adults, that can lead to this excessive mobilization of fatty acids and the subsequent health complications. So we're really interested in this, the lock, this restriction. What is preventing adipose tissue from being able to expand more effectively, and most importantly, how exercise may play a role in unlocking that ability to expand more effectively. So our working hypothesis is that regular exercise primes subcutaneous adipose tissue, so the primary source of our circulating fatty acids. So exercise primes adipose tissue to be more effective at energy storage during episodes of energy surplus and weight gain. So putting this into a cartoon, if you're overeating and typically living a sedentary lifestyle, that may lead to a more metabolically unfavorable condition of expanding adipose tissue, where the fat cells are very large, especially relative to the vasculature, the capillaries, and again in this cartoon shown in the red, the large adipocytes outstripping the ability of the capillaries to deliver blood and oxygen. The more fibrotic tissue within the adipose tissue, shown here as these hatches, and more inflammatory factors, shown as these triangles within the cell. Compared with, again, our hypothesis is that when if you're physically active, even when you are gaining weight, that may lead to a more metabolically favorable condition, smaller fat cells. Again, even though the gain of fat in our paradigm, we're comparing the same degree of fat mass and same degree of weight gain, but we contend that exercise, or our hypothesis is that exercise may lead to a more favorable expansion of the adipose tissue, smaller cells, more capillaries, less fibrosis, less inflammatory stress. So you may think weight gain and exercise, that's nuts, that we think of exercise and weight loss, but I want to put this in perspective of the known weight gain that we know occurs with most adults, even exercising adults, as we age. So here's body mass, one of many studies showing a body mass index, or weight to height ratio increasing throughout adulthood. And our contention, or our question, is does regular exercise modify adipose tissue's ability in ways to better accommodate the excessive body fat that most people accrue over time? And so to keep this pretty brief, I'm not going to be able to share you some of our preliminary data to help support our hypothesis, but we think exercise is doing a few different things. So we think that it is, and we have evidence to support the notion that exercise may actually help increase the production of new cells, new adipocytes. And again, you might think that's not a good thing, but actually it is. It enhances our ability to store those, the excessive, the added energy is under conditions when we are overeating and gaining weight. Exercise may modify the extracellular matrix or the fibrotic component of adipose tissue. And again, there's compelling evidence to suggest that that's the case. Exercise may induce an increase in new capillary formation, new blood vessel formation, the process of angiogenesis. And again, compelling evidence to suggest that with each session of exercise, there's signals that may induce that. And exercise may reduce adipose tissue inflammation. And importantly, it's not just that each of these individually is important. We believe that it's this integration of events. So if you can make new fat cells, if they can't expand because you have very rigid fibrotic tissue, that's not going to be helpful. If you have smaller cells that can expand, less fibrotic tissue, but the capillarization is not increased to feed that growing tissue as we gain weight, that's not good. So we contend, and again, part of our working hypothesis is that exercise is kind of at the hub of those multiple events that lead to improved health outcome in obesity. So in summary, with this slide, we think that exercise may hold the key to allow for more effective energy storage under conditions of weight gain. Certainly not saying that weight gain is favorable, but under conditions of weight gain that, again, most people experience, having a physically active lifestyle may induce these adaptations that we're actively testing in the lab that may induce a more favorable home for the added energy that we experience when under conditions when we overeat. So with that, I will thank you, and again, it's an honor to be a member of the Academy. Thank my lab group, my collaborators, and funding sources. So thank you.